During the air war over Vietnam, the Republic F-105 Thunderchief was one of America's most widely used aircraft. Many were shot down, but pilots grew to love the Thud. The F-105 Thunderchief was the first supersonic tactical fighter bomber that was developed from scratch for this role. All others before it were adaptations of aircraft that had originally been developed as pure fighters. The Thunderchief has the distinction of being the largest single-seat, single-engine fighter ever built. Although designed for the nuclear strike role, the Thunderchief gained distinction for the role it played in the Vietnam War in delivering conventional ordnance on targets in the north. It was the primary Air Force strike aircraft during Rolling Thunder operations against targets in North Vietnam, and the two-seat version went on to perform superlatively in the Wild Weasel flak suppression role. Although a large, heavy, and relatively sluggish maneuvering aircraft, the Thunderchief nevertheless managed to shoot down 27 enemy fighters during that conflict. The F-105 was known under several nicknames, such as Super Hog, Ultra Hog, and Lead Sled. But the aircraft is now remembered as the Thud. The price paid was relatively high. 397 of the 833 F-105s built, almost half the total, were lost in combat or in operational accidents during the Vietnam War. The F-105 could carry twice the bomb load of a World War II medium bomber. Here, its weapons crew is in the process of loading a 2,000-pound bomb in the bay amidships. It looks like a tight fit, but there's more room up there than meets the eye. Rockets and bombs can be loaded under the wings on hard points. Heat seekers are carried the furthest outboard. A 20-millimeter rotary cannon can fire up out of the nose. 6 barrels means hundreds of explosive rounds a minute to vaporize MiGs over Vietnam. But despite their awesome weapons load and their impressive kill record, they were ultimately seen to be just too heavy to turn with MiG-15s and 17s. The F-105 had its origins as far back as 1950. The F-84 Thunderstreak swept-wing fighter bomber had yet to make its first flight when in June 1950, the Air Force was already asking Republic Aircraft Corporation to initiate design studies for its successor. The new plane was to be primarily used in the nuclear strike role, but a secondary air-to-air capability was envisaged. A Mach 1.5 maximum speed limit was anticipated. The airframe was to be matched to the extremely exacting requirements of high-speed, low-level operation. Tasked solely as a bomber, the Thuds excelled at this low-level ground attack role. The first YF-105A rolled out of the factory in the autumn of 1955. It was shipped to Edwards Air Force Base for initial trials over the Mojave Desert. The first flight, the YF-105A, took place on October 22, 1955, with Republic test pilot Russell M. Roth at the controls. It easily exceeded the speed of sound on its first flight, although, as expected, the transonic drag was quite high. It was the largest and heaviest single-seat fighter ever built up to that time. The maximum speed attained that day was Mach 1.2, even though it was only powered by a J-57 engine and lacked a fuselage that was area-ruled. But these sort of problems were overcome quickly in subsequent testing and upgrade programs. The Republic design team came up with a large single-seat aircraft with a mid-mounted swept-back wing. The engine was fed by a pair of intakes mounted in the wing roots like the F-84 Thunderflash. The main landing gear retracted inwards into the wings. Since the undercarriage was so stocky, much of the internal volume in the wing was taken up with the stowed landing gear, leaving no space for internal fuel. All the fuel had to be carried in fuselage tanks or inside externally mounted drop tanks. A low-mounted, all-flying horizontal tail was fitted. Coming down after a mission, the Thud could weigh anywhere from 26,000 to 40,000 pounds, depending on the load of ordnance still aboard. A parachute deployment was sometimes necessary to help the ship stop on short runways. The F-105B was equipped with the MA-8 fire control system, which consisted of an E-50 sighting system operating in conjunction with an E-34 ranging radar gun sight mounted in the extreme nose and an E-30 bomb toss computer. The roomy fuselage had a capacious bomb bay in the belly. The bay was originally designed to carry a nuclear weapon, since the original role of the Thunderchief was tactical nuclear strike. From the outset, the aircraft was planned on a massive scale, with an internal bomb bay able to accommodate up to 8,000 pounds of nuclear weapons. This was usually an Mk-28 or Mk-43. However, an Mk-61 could be carried underneath the left or right inboard underwing pylon, and an Mk-57 or Mk-61 could be carried underneath the centerline pylon. Conventional ordnance could also be carried. As much as 4,000 pounds could be carried externally on 4 underwing pylons or an under-the-fuselage hardpoint. Later, as the use of nuclear weapons in warfare became less likely, the internal weapons bay was redesigned so that it could carry an additional fuel tank or other types of conventional weaponry. The F-105B was the initial production version of the Thunderchief. It was powered by the new high-thrust Pratt & Whitney J75 turbojet, rated at 23,500 pounds of thrust with afterburning. The airframe was extensively revised to take full advantage of the new J75 turbojet and had a fuselage that was reconfigured according to the area rule devised by Richard Whitcomb. It also differed from the YF-105A prototypes by having air intake ducts with swept-forward outer lips. These were designed to take in air at high speeds without choking the engine with supersonic shock waves. The area of the vertical fin was increased and made taller. A ram air intake was fitted to the base of the vertical fin, capturing air for the cooling of the aft end of the aircraft. The F-105 had a set of cloverleaf speed brakes attached to the end of the tailpipe. During braking, these pedals unfolded to stand at right angles to the airflow. A ventral fin was added to the bottom of the rear fuselage to provide good stability at high speeds. On December 16th, the aircraft was extensively damaged when Russell Brown was forced to make an emergency landing at Edwards Air Force Base after the right main landing gear had been torn away after having been inadvertently extended during high-speed flight. The aircraft was returned to the factory because of the damage, but repair costs turned out to be too high to justify returning it to flight status. On January 30th, 1957, the next YF-105B took off on its first flight. It, too, ended up on its belly after yet another landing gear failure. The problem was traced to an interference between the main gear and auxiliary air intakes and was fairly easily fixed. The distinctive swept-forward air intakes became the signature of the F-105. A boundary layer fence was located in front of each intake next to the fuselage. There was a variable plug inside each duct, which could be moved forwards or backwards to provide proper airflow to the engine as a function of Mach number. A set of auxiliary air inlets were provided that could be opened automatically whenever negative pressure existed in the ducts to provide needed airflow at low speeds. These air inlets could be opened only when the landing gear was extended, and interlocked, keeping the doors fully closed whenever the landing gear was retracted. Just in front of the engine compressor stage, there were a set of bleed doors in the intake ducting that could dump any excess airflow, which would tend to force the shock wave out of the duct throat. The Thunderchief series went through extensive testing, even during its operational period. Flying the aircraft to its very limits was the only way engineers could learn what improvements could be made in the aircraft. Even the results of the manufacturer's research would be adopted. While the first two YF-105As were under construction, Republic engineers learned of the difficulties being encountered by Convair with its YF-102 all-weather interceptor. In particular, engineering calculations of the transonic drag on the YF-102 had proven to be way off, and the aircraft could not exceed the speed of sound in level flight. Convair had found that the cure for the problem was the so-called area rule, in which the cross-sectional area of the fuselage is narrowed in the region of the wing roots, so that the total effective cross-section over the entire length of the airplane varies in a smooth and continuous fashion. Republic engineers decided to adopt the same sort of change for their F-105, the new WASP waist to be first incorporated on the F-105B. An immediate benefit from the reduction in drag produced by the adoption of the area rule was that full advantage could be taken of the increased thrust offered by the J-75 engine, making a Mach 2 high-altitude performance possible. Another innovation was the replacement of the plain flat intakes on the wing leading routes by two-dimensional sharp-edged forward-swept variable geometry intakes to improve their efficiency at high Mach numbers. This resulted in the F-105 having a distinctive M shape when seen in plan view. The flight testing program was intense in order to put all these improvements into action. It was one thing for engineers to come up with an idea, but it was quite another thing to have to make them work. The ultimate test for the F-105 was to send it into a spin and then successfully recover. A parachute system was devised to stabilize the aircraft while going through these maneuvers. It took great skill and even greater courage for the test pilots to undergo these tests. Still, the test pilots knew they had it easy compared to pilots who face these conditions in combat, when a few split seconds would mean the difference between life and death for the pilots flying the actual missions. Over time, they would work the bugs out of the system and make the Thunderchief into a powerful fighting machine. Here's a guy who's just lost engine power in a flameout. Several times he tries for a restart as he tries to get control out of his tumble. But in the meantime, he's falling fast. Hopefully, he has enough altitude to get control, restart, and pull up in time. It looks like he made it. Test pilots take this sort of risk all the time because combat pilots must know the limits of their aircraft and all about anything that could possibly go awry under a variety of conditions. The F-105D was the major production version of the Thunderchief series. It was essentially an all-weather variant of the basic day-only F-105B. It was to be capable of carrying the new Mk-43 nuclear weapon on either centerline or inboard underwing pylons. Externally, the ship differed from its predecessor in having a longer, wider nose in which was housed the avionics enabling its all-weather operation. In service, the 7 Tactical Air Command wings using the F-105D experienced lots of accidents and operational problems, which led to no less than 10 groundings. The aircraft came to be known under the rather derogatory nickname Thud, and had a questionable reputation for being too heavy, having too long a takeoff run, and being a maintenance nightmare. All throughout the early and mid-1960s, the F-105D continued to experience a series of accidents due to engine failures, fuel leaks, and malfunctions of the fuel venting system. These problems were not fully corrected until 1967. At the time of the design of the F-105, the Tactical Air Command was equipped with hose and drogue tankers, such as converted KB-50s, whereas boom tankers such as KC-97s and KC-135s had been assigned to SAC. In order that it be capable of being refueled in midair by the KB-50 fleet, the F-105 was fitted with a retractable midair refueling probe, which swung outward from a slot in the forward fuselage just ahead of the cockpit. Unfortunately, the retirement of the prop-driven K-50 tankers left the Tactical Air Command dependent on SAC's boom tankers. Although a hose extension could be attached to the end of the flying boom of the KC-135 so that it could handle probe and drogue receiving aircraft, it was thought that it would be beneficial for the Tactical Air Command to have aircraft that were fully compatible with SAC booms. The new air-to-air refueling system was a success, especially given the fact that not all the older tankers were leaving service all at once. For quite a while, both the KB-50s and the newer KC-135s were flying at the same time. It took time to bring enough of the new tankers online to fully replace the older fleet. Eventually, almost all of the Air Force's prop-driven combat airplanes were replaced by jets. A few exceptions included the A-1 Skyraider and some older C-47s that were converted to gunships in Vietnam. Here, the newer refueling system is demonstrated. Note that the old basket probe is gone, replaced by the flying boom. For budgeting reasons, only the last few F-105Ds off the production line were given this new capability of refueling from either a flying boom or a hose drogue type of tanker. This was done by fitting a flush-mounted retractable door-type receptacle in front of the windshield, which could accept a flying boom type of mid-air refueling probe. But notwithstanding these earlier decisions, some earlier F-105Ds were retrofitted with these receptacles. Even with the new system in place, it still required a steady hand on the controls to avoid a sudden break-off and consequent wastage of fuel. Now topped off, this stud can now extend its cap, or combat air patrol. This method of aerial refueling means that a ship can stay aloft indefinitely, subject only to pilot relief. When it's time for that, the ship can land quickly and be up in the air once more within a few minutes, manned by a fresh pilot. The F-105D was destined to become a major participant in the war in Vietnam. In response to the Tonkin Gulf incident, 8 F-105s were sent to Thailand. The first action took place when flying a rescue mission over Laos. The planes attacked an anti-aircraft site in the Plain of Jars. On January 13, 1965, 16 aircraft destroyed a bridge at Ben Ken in northern Laos with 750-pound bombs and bullpup missiles. On March 1, 1965, Operation Rolling Thunder began, which was the systematic bombing of North Vietnam that was destined to last until 1968. The Thunderchief made an excellent tactical bomber. With the exception of the ammunition for the cannon, all the ordnance was carried externally. On a typical mission over North Vietnam, the F-105D would carry 6 750-pound bombs or 5 1,000-pounders. Along with 2 450 U.S. gallon drop tanks. The D could also carry the Martin AGM-12 bullpup air-to-surface missile, but this weapon was to prove almost useless in Vietnam against hardened targets. The F-105D could carry 2.75-inch rocket pods, napalm canisters, as well as 4 AIM-9 Sidewinder infrared homing air-to-air missiles. The 20-millimeter cannon proved invaluable in the dual role of air-to-air combat and ground strafing. With its size and range, the F-105D could carry twice the bomb load and further and faster than the F-100. However, the F-105D was somewhat less successful as a fighter, often being hard-pressed by enemy MiG-17 and MiG-21 fighters. It had a wing loading that was much too high for it to be able to maneuver effectively against the more nimble MiGs. Since all the ordnance was carried externally, maximum performance could only be reached once the bombs and rockets had been released and the aircraft was departing the target. However, when jumped by MiGs, the enormous thrust of the J-75 engine enabled a cleaned-up Thunderchief to go supersonic on the deck, quickly leaving its pursuers behind in a cloud of half-burned kerosene. When forced to fight, the F-105D did manage to shoot down 27 enemy fighters during the course of 1966 and 1967. Most of these kills were by the 20-millimeter Vulcan cannon, although 2 were down by Sidewinders. Over 20,000 combat missions were flown by Thunderchiefs in Vietnam. A total of over 350 Thunderchiefs were lost in combat, most of them to North Vietnamese anti-aircraft fire. This was over half of all the Thunderchiefs built. 126 F-105s were lost in 1966 alone, 103 of them to AAA anti-aircraft fire. At one point in 1965-1968, it was calculated that an F-105 pilot stood only a 75% chance of surviving 100 missions over North Vietnam. Although the total number of losses was rather high, the actual loss rate was not that bad, considering the total number of missions that were flown. Following their withdrawal from Southeast Asia, the few Thunderchiefs to survive combat in Vietnam served with active-duty Air Force units for several more years. The last Air Force Reserve unit to operate the F-105D made the last flight with the type on February 25, 1984. The old Chief was gone, but not forgotten. Vintage air units around the world will no doubt be flying them soon.